Welcome to True Projects. In this video, we are going to explain about the project title Personality Classification of Text through Machine Learning and Deep Learning, a review. Before diving into the execution, let me give you an overview of the project. The project aims to develop a sophisticated system capable of automatically analyzing text data to predict personality traits. It employs both machine learning and deep learning techniques to categorize text inputs into predefined traits such as extraversion, agreeableness, conscientiousness, neuroticism, and openness to experience. By accurately predicting these traits, the system enables various applications, including personalized recommendation system, social media analysis, and psychological research, simplifying a process usually done manually or through rigid rules. Traditional methods of personality classification involve manual annotation by experts or rule based approaches defining criteria for each trait. However, these methods have drawbacks. Manual annotation is slow, subjective, and not scalable with large text volumes. Rule based methods struggle with the subtleties of human language. The proposed system combines various machine learning and deep learning techniques such as RNN, recurrent neural network, CNN, convolutional neural network, LSTM, long short term memory, ensemble models, regression, Navy Bayes, random forest, K nearest neighbor KNN, support vector machine SVM, stacking classifier, and transformer based models like BERT, Roberta, Distilbert, Albert, FLAN-T5, GPT, and ExcelNet. By utilizing the strength of each method, it seeks to accurately identify personality trait from text data. This contributes to progress in natural language processing and psychological research by providing more precise insights into human behavior and language use. The system's performance will be assessed using standard metrics like accuracy, precision, recall, and FN score. These metrics measure how well the system predicts personality traits from text data. By comparing these scores across different algorithms and approaches, we can determine which method are most effective for personality classification. This analysis helps identify the strengths and weaknesses of each technique, guiding future improvements and research directions. The project benefits a wide range of stakeholders by automating text analysis to predict personality trait. It advances psychological research, informs marketing strategies, improves social media user experiences, assists in mental health diagnosis and treatment, guides educational interventions, and improves personal development through self awareness. Its broad applicability across domains highlights its significance in leveraging technology for understanding human behavior and enhancing various aspects of society. To implement this project, we need software and hardware requirements. Hardware requirements of the project are operating system of Windows, processor of Wi-Fi and above, RAM of 8 GB and above, hard disk of 25 GB and above. Software requirements of the project are application is Anaconda, primary language is Python, front-end framework is Flask, backend framework is Jupyter Notebook, database is SQLite 3, front-end technologies used in the project are HTML, CSS, JavaScript, and Bootstrap 4. Algorithms used. These are the algorithms built in the project for personality classification of text. We have built these algorithms to compare the performance with different evaluation metrics like accuracy, precision, recall, and FN score. And here, the LSTM plus GRU ensemble model outperformed the other algorithms. That is the reason we have deployed it in the front end. So let me explain you what LSTM plus GRU model is. The LSTM plus GRU ensemble model is a combination of two different types of recurrent neural network, RNN architectures, long short-term memory LSTM, and gated recurrent unit GRU. LSTM and GRU are both popular architectures used in sequential data processing tasks such as natural language processing NLP. They are designed to address the vanishing gradient problem and capture long-term dependencies in sequential data. In an ensemble model, multiple individual models are combined to make predictions. In this case, both LSTM and GRU models are trained separately on the same data. The predictions from these individual models are then combined, typically by averaging their outputs or using more complex techniques like stacking or blending. The goal of using an ensemble of LSTM and GRU model is to leverage the strengths of each architecture. LSTM is known for its ability to capture long-term dependencies, while GRU is simpler and computationally more efficient. By combining these models, the ensemble can potentially improve prediction accuracy and robustness compared to using either architecture alone. To execute this project, first we need to open the code folder, which contains the project source code files. So here, this is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. This is the templates folder. This folder contains all the HTML pages used in the project. It includes files like index.html, home.html, about.html, and more, which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. In this project, we have utilized MBTI dataset. So this is the dataset. So here, these are the posts, and this is the target variable in which we have different types. So this data set will be pre-processed and then it will be stored in the processed data. Let us open the processed data. So here, this is the processed data. So here we can see the posts. These are the posts. And here, this is the target variable in which we are having different types for personality classification. So this processed data is used to train the algorithms. Now close this data. And here, this is the sample data set in which we have the test cases which we will use during the execution. So here we can see the posts, and here we have the target variable in which we are having different types. Now close this. So here, this is the notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is model file which contains algorithm information which will be loaded into the project code during runtime. This is signup.db file. This file is the database file used to store user information. First, we need to copy the path of the code folder from the address bar of the file explorer. So here I'm copying the path. Now open the Anaconda prompt. Use the cd command followed by a space and paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Compile the app.py file using the command python space app.py. So here I'm typing python space app.py and hit enter. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address. localhost, which is this, and port, which is this. Now copy this local link provided by the Flask framework. I'm copying the link and paste this copied link into any web browser. I usually prefer Google Chrome and hit enter. The homepage of the project is displayed in the browser. This is the front end built using Flask framework. So if we are a new user, we need to register first. So click on sign up link here. So here we need to enter all these details to register. But I have already registered, so click on sign in. So here we need to enter the username and the password, which are static, and then click on login. We need to enter the correct username and password, and then click on login. We have logged in successfully and we are redirected to the prediction page. So here we need to enter the text, and after entering the text, the application will classify the personality trait based on the text. So here from the sample data set, that is from the test cases, I'm entering this text. Now click on predict button. So here we can see the result. The personality trait is neuroticism. Neuroticism, sometimes also called emotional stability, measures the tendency to experience negative emotions such as anxiety, depression, and vulnerability, as opposed to emotional resilience and stability. Individuals high in neuroticism are prone to worry, mood swings, and emotional instability, while those low in neuroticism tend to be more emotionally resilient, calm, and emotionally stable. Let us enter some more messages. Click on home link here. So again, from the test cases, I'm entering this text. Now click on predict button. So here, the result is the personality trait is agreeableness. Agreeableness reflects the degree to which a person is cooperative, compassionate, and trusting versus antagonistic, suspicious, and competitive. Those high in agreeableness are empathetic, considerate, and eager to help others, while those low in agreeableness may be more skeptical, critical, and less concerned with others' well being. Let us enter some more text. Click on home link here. So here I'm entering one more text. So this is the text which I want to enter. Now click on predict button. So here the personality trait is conscientiousness. Conscientiousness refers to the level of organization, responsibility, and dependability versus impulsiveness, carelessness, and lack of direction. Conscientious individuals are diligent, disciplined, and detail oriented, often setting and achieving goals effectively. In contrast, those low in conscientiousness struggle with procrastination, disorganization, and lack of follow through. Let us enter some more text. Click on home link here. So here I'm entering one more text. So here this is the text which I want to enter. Now click on predict button. So here the personality trait is extraversion. This trait refers to the extent to which someone is outgoing and energetic versus reserved, quiet, and solitary. Extraverted individuals tend to be assertive, talkative, and enjoy being around other people, while introverted individuals prefer solitude and are more thoughtful and tend to engage in less social activity. Let us enter some more text. Click on home link here. So here from the test cases again, I'm entering this text, copy this. So this is the text which I have entered. Now click on predict button. So here the personality trait is openness. Openness to experience reflects the degree of curiosity, creativity, and willingness to try new things versus preference for routine, tradition, and familiarity. Open individuals are imaginative, intellectually curious, and open minded, enjoying novelty, variety, and unconventional ideas. On the other hand, individuals low in openness may be more conventional, preferring familiar routines and ideas over new experiences and unconventional thinking. In this way, by entering the text, we will classify the personality trait. In this project, we have classified 5 personality traits known as Big Five personality trait, also known as the 5 factor model. These 5 traits, which are openness, extraversion, conscientiousness, neuroticism, and agreeableness, provide a comprehensive framework for understanding and describing individual differences in personality across various contexts and cultures. Now click on About link here. So here, this is the donut graph, which represents the distribution of personality types. This is the accuracy curve of LSTM plus GRU. And here we have the comparison graphs for different evaluation metrics: accuracy, FN score, precision, and recall. So here this is the accuracy comparison graph. Here on the x-axis we have accuracy score, and on the y-axis we have algorithm name. Accuracy is a measure of how well a model correctly predicts outcomes. It represents the proportion of correctly classified instances among all instances evaluated. This is FN comparison graph. Here on the x-axis, this is the precision comparison graph. Here on the x-axis, we have precision score, and on the y-axis, we have algorithm name. Precision is a measure of the correctness of positive predictions made by a classifier. And this is the recall comparison graph. Here on the x-axis, we have recall score, and on the y-axis, we have algorithm name. Recall is a measure of the classifier's ability to correctly identify all relevant instances from a data set. And this is the F1 comparison graph. Here on the x-axis, we have F1 score, and on the y-axis, we have algorithm name. F1 score combines precision and recall into a single value. It provides a balance between precision and recall, taking into account both false positives and false negatives. Now click on sign out link here.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.